Welcome everyone to Hands-On Activities plus Technology equals Mathematical Understanding through Authentic Modeling. I am Tom Beatini. I would like to share one of my favorite activities with you this morning. It's a low floor, high ceiling activity that students can participate and work at their own level of engagement. This ensures educational equity. I will reference how this can be adapted at multiple levels a little bit later on, but this is set up this morning for an Algebra 1 class. Some of the goals for today. It's to demonstrate a classroom activity that is classroom ready. I have used it with success in my classes. I have shared this with other teachers who have used it successfully. And it's, as I said, one of my favorite activities because it makes math come alive for students. It's an opportunity for students in an inquiry. You can get the students to create their own learning. You are not the sage on the stage, but the guide on the side, as you can redirect students when they have troubles and ask guiding questions as they are working through the activity. We can integrate use of technology, whether it is a graphing calculator or a computer program such as Desmos or ClassPad.net. Students can use this at the end of the activity, depending upon their level. One of the things that is important about this activity is that you can connect algebraic representations. In order for students to become proficient algebraically, they need to be able to use these different representations and move back and forth between them with proficiency and ease. We also want to talk about some of the strands of the standards, specifically the modeling strand, which is at the end of the standards. This strand ties together the functions, algebra, and statistics strands of the standards and is kind of a unifier for all of them. So let's talk about our activity. This activity is what I affectionately call the knots lab because, as you can see, we have 4 different ropes with different diameters. And what students will do is they will measure an unknotted rope. After they measure the unknotted rope, they will start tying knots in it as close to the end as possible. So this way they can maximize the number of knots that they have. So here we have the unknotted rope. And here we have a rope with 7 knots. And as the students are tying their knots, what they are doing is they are collecting data, measuring the length of the rope each time, and writing this down in an activity sheet that is provided with them. That is the handout. So let's go to the handout. And as you can see, we have the directions here. There is one handout for every 2 students. And you want to ask them at the beginning to make a prediction about what's going to happen every time they tie a knot in the rope. And we have a space here for them to enter their data in the table. With the ropes that I've provided, you can get anywhere from 0 to 7 knots, depending upon the thickness of the rope. As I said earlier, this activity can be done on many different levels. And one of the things we want to look at is we want to see what the data is going to look like after we plot, which will make things come to life even more. So I have provided students with a grid, and what they have to do is they've got to label their axes and put in a scale, title it. These are basic proficiencies that students need to do in an algebra class, knowing how to set up a scale and plot points. So we have the length of the rope in centimeters on the vertical axis, the number of knots on the horizontal axis. And as you can see, we have 7 points that are plotted beginning up here on the y-axis. And if you notice, I have some points circled. Well, those points are used to come up with a mathematical model for this data. So what we want students to be able to do is to use a piece of linguini to find an eyeball line of best fit to help them identify which 2 points they want to use, and then use those 2 points to come up with a mathematical model. Now, if you notice on the grid, we have a downhill line with a negative slope, and the Knots Lab is one of the few activities I know where you collect linear data and have a negative slope or negative rate of change. So now we identified our points that I have circled, which are 263.2 and 639.5. And using point slope form, students can come up with the equation of the line, which is here in red. Alternatively, I used 2 other points just to see how close we will come. And if you notice, the rates of change, the slopes are very similar, and the y-intercepts are very similar as well. So now it is time for the thought-provoking questions. Number 5, regarding the slope of the line. Students will probably say it's negative 5.93, but we have to put that in context. So in order to get students to put the slope in context or the rate of change in context, I say to them, give me a sentence with that number in it. What does negative 5.93 mean? So what I want students to say is, for every additional knot we tie in the rope, the length of the rope decreases by 5.93 centimeters. The y-intercept, well, that is the value of y when x equals 0. So based on our equation, it is 75.08. Originally, when we measured our rope, going back to the data, it was 74.4, which is very close. Now, let's think about the thickness of the rope. The thickness of the rope will affect the slope or rate of change. If we had a thicker rope, the rate of change will be much more negative. So with a thicker rope, we might have a rate of change of negative 7.5. A thinner rope might have a rate of change of negative 3.6. And that is the reason why I supply different thickness ropes to the class. So not everybody comes up with the same data. Now, the type of knot, what does that have to do with the results? Now, here I am holding up a rope, and I have 2 different size knots, 2 different type knots. By my left hand, I have a figure-8 knot. By my right hand, I have an overhand knot, which is what I tied in the original rope. The type of knot will affect the rate of change. So this is a variation you could do with this activity. Now, the next thing we want students to talk about is the x-intercept, the maximum number of knots. So to find the x-intercept, we need to substitute in 0 for y and solve for x. And we get x equals 12.66. So theoretically, we could tie 12.66 knots in the rope. But now let's talk about the real world meaning of the x-intercept. Since the length of the rope will be 0 in this particular case, we are saying that we could tie 12.66 knots in the rope and have the length be 0. Now that is an impossibility. You can't have a rope with 12.66 knots in it and have 0 length. And if we go back to the graph, if you notice, after I graphed the line, we got about 12.5, which is pretty close. Now let's talk about making some predictions using the equation. We have some information here in number 11 so that students can write a model for the equation of a rope that is having knots tied in it. Now, I said before, this can be done at multiple levels. If you have a lower level class, what you could have students do, adapting this activity, which, as I said before, is set up for an Algebra 1 class, to find the rate of change and the differences between the lengths when each knot is tied. In an Algebra 1 class, you could have students do this by hand and not do number 12, unless they have practice using a graphing utility. You could if you wanted to. In an Algebra 2 class, we might talk about having the students graph it by hand, come up with an equation, then have the calculator do it, and then talk about some of the statistical features. So let's go back to the PowerPoint and talk about number 12 and see our results. So here is our data. Here is the scatter plot, which looks very similar to what we had before. And here are the two mathematical models. As you can see, we have the hand calculated line on the left, the linear regression model from the calculator on the right, and the numbers are indeed very close when it comes to the rate of change. Negative 5.93 compared to negative 5.85. The y-intercepts are also very close. 75.08 compared to 74.8. And if we were in an Algebra 2 class, we could start talking about correlation coefficients, which is the value of R. The closer it is to -1, in the case of a model with a negative rate of change, the better the fit. The R squared value is the coefficient of determination, which tells you what % of our data our model describes. So these are some things that could be used in an Algebra 2 class. In a statistics class, you could have the students do it by hand, and then you could have them try to come up with their own model using features of correlation, calculating the correlation coefficient by hand and comparing that to what they would get with the calculator. So when we're talking about data collection, what we want to do is we want to keep it real. Manufactured data is no fun to use in the classroom. It doesn't make things exciting. It doesn't get students engaged. So it makes it much more fun for your students and yourself. You're able to make mathematical connections. You're able to provide them with some rigor. You're able to help them take ownership of their own learning while you pose purposeful questions. The drawback is they take time. Here are some examples of activities you can use to collect data using one variable: pulse rates, coins in pockets, amount of change, heights, shoe sizes. And you can modify these at various levels. You could talk about mean, median, mode for one variable data. Then you could, in a higher level class, you could start talking about standard deviation. And then after that, you could talk about normalizing data and the standard normal curve. Examples of data collection using two variables: we have the wave, which we see at sporting events. We can compare student height versus shoe size. And we could do a bucket or book brigade, which is when you have a line of people and they pass a bucket or a book down the line and you time it. I want to thank you very much for your attention this morning, and I hope that you can use this activity in your classes.